to this video for Math Review, and this one is going to be on probability. And there are many things we could talk about with probability, but we're going to try to keep things as simple as possible. We're going to first talk about single events, which is just like it sounds, rolling one die. Tossing one coin. Things like that. The probability of something happening equals just the outcomes of A divided by the total outcomes. So the probability of getting a 6, one chance on one die, 6 total outcomes. All there is to single event probability. Multiple events. Tossing 2 coins. Rolling 2 dice, and so on. Now there are a few things that could happen here. You could have probability of A and B where A and B do not exist on one outcome together. Easiest way to think of this is drawing 2 cards from a deck. Probability of getting a 5 and a king. There is no card that is both a 5 and a king at the same time. These events are mutually exclusive. In this case, probability of A and B would equal probability of A times the probability of B. But what about probability of A or B? Same rules apply. Which means, do they exist together? If no, like a 5 or a king, probability of A or B equals probability of A plus probability of B. So if no. If yes, 5 or a red card, let's say, probability of A or B equals probability of A plus probability of B minus the probability of A and B. Let's take this example. Probability of getting a 5 is 4 out of 52. There are 4 5s in the deck of cards. The probability of getting a red card is 26 out of 52, half the deck. Now, how many times do both a red card and a 4 card exist together? Well, that would be 2 out of 52. Don't believe me? Let's do it real quick over here. So we'd have 4 over 52 times 13 over 52. Oops, sorry, 26. Four times 26 is 104. Out of 52 times 52 is 2704. Which this can reduce down to 2 out of 52. Really reduces to 1 out of 26, but we want to keep things in terms of 52. So we get 4 plus 26 is 30, minus 2 is 28 out of 52. So the key is to think of the sample space. Think of the outcomes that could possibly happen. If they exist together, you do it this way. If they don't exist together, you do it this way. All right, there is one more probability occurrence that we were going to do. And that's called conditional. Which is the probability that A happens given B occurs. So what is probability of getting let's just say a 3 given you draw a club? And probability of A given B equals the probability of A and B divided by the probability of B. So probability of 3 given a club will be probability of 3 times the probability of a club divided by probability of a club. That's going to be fun to try to squeeze in here. Let's just go to the next page. So we're looking at probability of a 3 times probability of a club over probability of a club. Now, I know what a lot of people are thinking here. You could cancel these out. Well, don't. Alright, don't cancel until the end. So probability of a 3 is 4 out of 52, times probability of a club is 13 out of 52, divided by 13 out of 52. We get 52 out of, I'm going to just leave it as 52 squared for now, all over 13 over 52, which is the same thing as this. So we're going to do copy, change, flip. Oops. I've got 52 squared on top. And 52 squared on the bottom. They're going to cancel out. I'm left with 1 over 13. And if you think about it, that makes sense. Basically, you're saying that you're only pulling from the clubs, and there's only 1 out of 13 clubs. That's a 3. And that's the main thing with outcome-based probability. So that's the first video. I'll see you in the second one.